Hello all, welcome to my channel. I'm back with another video. In this video, we will be discussing some of the integration services which are available at AWS and when to use them. So let's get started. AWS offers many services which can be used as an integration service. The job or the purpose of these integration services is to help users create a decoupled system by separating the producer and the consumer, and this allows this decoupled design allows the users to scale the producers and consumers independently, and they can process means the consumer doesn't have to know the architecture or the protocol that is being followed by the producer, as long as it abides by the services what you call message format or protocols. So in that way we can have independent scaling, and that allows us to build systems which are more robust. But there is one, because we have many services, it becomes a challenge to choose which service, because all of them share the common messaging models and architecture. Like all of them have uh, kind of an asynchronous messaging approach or information exchange approach, we can say. So there are different things when we are talking about a message being sent and a message being received. Is we have to understand there are different aspects. Based on that, we can take decisions. One is what is the data or control flow, what are the interaction model, what are the data formats, partial failures, how is the state handle, how is error handling happens, backflow, back off, retries, whether it's a pub sub or it's a point-to-point communication, whether we are doing push-based solution or a push-based solution, pull-based solution, sorry, whether the message processing or the acknowledgement should be synchronous versus. So there are different aspects while we decide the information exchange or the message blocking system. So we will discuss on these how we can decide the right integration service. But before we go that, we have certain these are will be a quick refresher of which services does what. So AWS SQS is a point-to-point simple queue. This is a polling based system. So what happens is we send a message to a queue. It is consumed by a uh, consumer and it gets deleted. A user will explicitly delete it, and a user has to constantly polls to see if the new messages are available. This is very highly scalable, very it is uh, cost effective. There we have an option of using a FIFO based queue as well, which allows us to do an ordering. And but in general, if we use a standard queue, there is no guaranteed ordering in there. And the retention wise, it is at 14 days replay, but there is no replay. So once the message is consumed, or if we want to replay the set of events that has happened or the set of messages that we have published again, it won't be possible. We have to produce those messages again. So that's one for the SQS. SNS is a fan out pub-sub system. What it allows is to send same message to multiple receivers. It is a real-time push-based system which sends notification to the subscribers. Again, there is no replay. If we want to do any replay of the events, we have to generate the events at the producer side. Similarly, unlike SQS, which has a 14-day retention, this doesn't have any retention. So if the message when was published, if the subscriber was down, it won't get the message. So it is used for notification alerts and Lambda triggers. Then we have EventBridge. So EventBridge is something which is, I will say, an evolution over the messaging protocol that was there. So if we add a particular structure, in a sense that we add a particular metadata and strict that metadata and the format of that event, we get EventBridge, which has it routes based on certain rules. It allows us to do SaaS integration. It has a schema registry. It has a 24-hour of retention, and it acts as an event a sync event mesh. Then we have Amazon MQ, which is an enterprise messaging I mean, which supports many enterprise messaging protocols like JMS, AMQP, MQTT, Stomp. This guarantees an order delivery. This is a traditional brokers which is coming from on-prem. So if someone has a system or application which is already being using, let's say RabbitMQ or something in their on-prem, and they want to just modernize that solution into cloud, they can, if they want a lift and shift kind of solution, Amazon MQ has that capability that it can work with the existing things, and that's when where this is is heavily used. Then we have Amazon Kinesis, which is nothing but a stream processing engine. So it has capability of replay. It has a long retention period. We can store up data up to 1 year. It orders the data within the shard. So it has concept of shard similar to how Kafka has partitions. It is used for real-time analytics, and it is a serverless streaming service. So we don't have to manage any servers. We just can decide. We tell upfront the throughput numbers, and it will uh, try to match that throughput number whenever we have input live traffic going on. So it automatically scales up and doesn't scale down, but scales up if we have burst. MSK is a managed service for Kafka, which is full. It has full Kafka ecosystems. What do you call tools and services enabled. Like we can do replay, we can have partitions, we can have consumer groups, we can store the messages for as long as we want, and it allows us to build custom or complex streaming pipelines. So this is a flow of to decide which service to choose and when. So let's see how we can leverage that and see what we can do with or how we decide on the right structure for us to be able to serve the customers that we are interested in. So if we see, it starts with this point where we have uh, a decision that we want to make is first we want to identify whether we need a message queue or we need an event or a stream bus. Uh, the logic for that is if we want to process data in real time, we will be going at, or let's say there is a concept of last 5 minutes, last 10 minutes, or that kind of scenario we have, we can go ahead with stream solution, or we can go ahead, let's say if it has a certain set of events needs to be processed in a certain order or certain way, then we can go ahead with event bus. Message queue is you simply send a message and then that gets consumed. So that are three different kinds. Let's say if we go let's say we say that okay, we need a queuing system. So is that queuing system a point-to-point queuing system, or the messaging system that needs to be a pub sub, or it's in streaming data? So based on these three decisions, we will have these three different paths. So let's say we have point-to-point communication that we want. So is this a push-based or a pull-based? So if it is a pull-based model where pull in a sense a poll-based model where there will be a consumer which continuously pull looks for a messages and then process it. So in that case, we can go ahead with SQS, which has all the features that we have already discussed. And if we need a FIFO solution, like means ordering, then we can go ahead with SQS FIFO. Otherwise, we can go ahead with SQS standard. Then let's say in the push-based solution, if we needed, we can go ahead with Amazon MQ, where we have queues defined and we can leverage that. Or if we have legacy protocols, we can go ahead with Rabbit MQ or something like that. So that is on the point-to-point system. Then we have PubSub. So in PubSub, we have uh, approaches like if we need simple fan out, we can go ahead with SNS. Fan out, as I mentioned, is a process where one single message gets sent to multiple consumers, and it can decide what message they want to filter ahead with. So if you want filtering enabled, so you can we will have to just send the data or the message with an attributes, and then we can enable attribute based filtering on the SNS topic. And let's say if we want certain routing and schema management as well, or we want to integrate with third-party services, for example, Salesforce, Zendesk, or Autodesk. So those kind of solutions, if we need to get the events coming from, then we can go ahead with EventBridge, which is again a rule-based routing system. It has complex routing algorithms that it can define, and we can consume these messages from either directly using Lambda in between or directly publishing it to SQS as well. Then we have streaming data. So in streaming data, we have two solutions. If we are okay with serverless solutions, we can go ahead with Kinesis data stream, which allows us to directly consume per shard basis. And if we have use cases of, let's say we already have, we don't want to go to serverless and we have people we can manage, or let's say if we want to continue in the open source space, we can go ahead with MSK, which is a managed streaming solution for Kafka. It has two flavors. We can go ahead with MSK or MSK serverless, and then we can consume these messages from this. So this was a brief overview of how we decide which particular integration service we want to choose for our platform. So this was it for this video. Um, we will touch again for uh, something else in this video series. So thanks. Have a nice day.